Yellow. We continue section 8.3, conditional probability, intersection, and independence. And we have dealt with the first objective, calculating conditional probability, and now we move to the student will be able to use the product rule to calculate the probability of the intersection of two events and in future videos we will talk about probability trees and we'll talk about independent dependent events. But now the big focus is on this product rule. Little derivation here. Here's a formula that we know about conditional probability. Probability A given B is probability A and B divided by the probability of B. And we know that, and we certainly could multiply both sides of this equation by the probability of B to get this equation. Second line here is just saying that you can interchange A and B in all of that. Well, if you take that and you isolate probability of A and B, and it's A intersect B, but it's A and B. Sometimes you see it written that way, A and B. And in problems, in word problems for which you're trying to calculate a probability, you always think of it as A and B. Both of them have to happen. A lot of times the word and, usually the word and is in there. And if not, you have to see it there even though it's not there. But of course, probability A and B both happen is the same thing as the probability that B and A both happen. Now, if you multiply both sides of the top equation by probability of B, you get this form of the expression. If you go back to the second line and multiply both sides by probability of A, you get this form. I like this form here. Probability A and B is, it's going to be the same as this here, except that I'm going to use the commutative property and switch these two factors. Probability of A times probability of B. Now, I'm going to freeze this. I'm going to pause this because there's going to be a comparison between what I've written so far and a future formula. But probability of A times probability of B given A. That's the version of it that I like. Example. 2 cards are drawn without replacement from an ordinary deck of cards. Find the probability that 2 clubs are drawn in succession. Okay, now you look at that and you don't see an and. But really, there's really an and there. That's saying that we're talking about the event that a club is drawn on the first draw and a club is drawn on the second draw, C1 and C2. Well, by the formula that I just gave you, that's probability C1 times the probability of C2 given C1. So just using the formula, the one I wrote at the bottom, interestingly, they go back to that form of it. Okay, so what was that? Probability A and B is probability of A times probability of B given A. Okay, and here we're just replacing A with C1 and B with C2. And so it'll be probability a club is drawn on the first draw times the probability of that a club was drawn on the second draw, given that a club was drawn on the first draw. And what is this? Well, probability, the first probability ought to be straightforward. Probability club on the first draw, well, let's see. If you know a deck of cards, you know there are 13 clubs in a 52 card deck. And so 1/4 of the cards are clubs. And so the first factor is 13 50-seconds. But now here is where it gets interesting, because we have to find the probability of club on the second draw given club on the first draw. And if a club is drawn on the first draw and the two cards are drawn without replacement, then we have only 12 remaining clubs in the deck, because once the first club is drawn, it's not put back into the deck. There are 12 remaining clubs out of the 13 and 51 remaining cards out of the 52. So probability of club on the second draw, given that you had a club on the first draw, is this 12 over 51. And so then we do the arithmetic. As we said, 13 50-seconds is really just 1/4. And 12 51sts, well, if we divide top and bottom by 3, we get 4 17ths. Well, then the 4's can cancel, and we have 1 17th for the probability that two clubs are drawn if you're drawing without replacement. One draw and another draw, it's very unlikely that you're going to get two clubs, but it could happen. So that's an example of using the product rule. Probability one event and another event is probability of the first event plus probability of the second event, given that the first event happened.